Assalamu guys, Ifan back again with another video, and today we are going to be looking at the three types of uninterruptible power supplies, also known as for short UPSs. Now, the three types of UPSs that we are going to be looking at in this video are the online UPS. Start. Assalamu guys, Ifan back again with another video, and today we are going to be looking at three common types of uninterruptible power supplies, also short for also called UPSs. Now, the three types of UPSs that we are going to be looking at today is the offline UPS, and then we have a type that's called a line interactive UPS, and then we have the third kind that we'll be looking at is the double conversion UPS, also known as the online UPS. Now, what differentiates these UPSs? How do you figure out which UPS is better than the other one? In order to look at that, is what you need to do is first look at what the true measure of any UPS system would be. Now, the first one would be the first factor that you will looking at is power failure. Now, power failure is the total loss of utility power. So the utility company uh, develops a fault, a feeder trips, or something like that, and there is a total loss of utility power. Now, the second type of problem that we may have is called a power sag. Now, this is a low voltage which is only there for a short period of time. Okay, a very short period of time, voltage that goes low for a very short period of time, that's called a power sag. Then we have what we call a power surge, also known as power spike. Now, this is again a very short term, high voltage. Okay, power sag was a short term, low voltage. Power surge is a short term, high voltage, and usually you say that's 110% higher than the normal voltage. Then the fourth factor that you would look at is the under voltage, also called brownout. Now, what that is, the voltage is lower than what it should be for an extended period of time. It could be for a few minutes to, for hours or for days. Now, a UPS, a good UPS should also account for that. And that's one of the factors that we look at when you're deciding which UPS you want to get. Now, this is common in some places during the summer months when the load on the electrical grid is more because a lot of people are running their air conditioning systems. Then we have the over voltage, and that is essentially the opposite of under voltage. Essentially, what it is higher line voltage for extended period of time. Okay, it could be for a few minutes, few hours, few days, weeks. Anytime you have voltage that's above what it should be for extended period of time, that's called the over voltage. Then you have another issue called the electrical line noise. Right now, what that is a high power frequency wave that's usually caused by radio frequency interference, also called for short RFI, or electromagnetic interference EMI. And what that does is it creates noise on your power line. That's another type of issue that you may have facing when you're using utility power. So that's your sixth issue. Now, in the US and North America mostly, the frequency is 60 hertz as opposed to Europe, which tends to be 50 hertz. So if you have voltage fluctuating, I'm sorry, not voltage, but the frequency fluctuating in North America, if it's when it's supposed to be 60, you've got 65 hertz, or then 58 hertz and 55 hertz, then back to 60 hertz. Or in Europe, you could, where it should be 50 hertz solid, you're getting 55 or 58, and then 52, then 48. So that the variation in the frequency is also an issue that can damage your appliances or equipment that's downstream. So you need to kind of keep an eye on that for, for that too. Then you have the switching transient. That is when the voltage goes under, you have under voltage for an extremely short period of time. It's, less than like a few nanoseconds. But if your equipment is very sensitive, it may be affected by this. But most of the equipment would be able to tolerate that. But like I said, sensitive equipment would would stand to get damaged by the switching transient. And then the last type we have is the harmonic distortion. That is, the electric power that you have, the utility that the utility company supply to your homes is supposed to be a perfect sine wave. Now, if uh, the if it's not a perfect sine wave, and that may be because of certain high loads, the wave may be distorted. That can also harm your appliances, and that's the ninth type of issue that you have to look at when you're selecting your UPS system. Okay. Now, let's look at the first type of UPS, that is the offline UPS. Okay. Now, in the figure, you see if you've got 220 or 230 volts coming in, it goes through a battery charger, which charges the battery, and then you have an inverter that supplies 230 out in case of power failure. Now, the offline UPS is the simplest and the least expensive because the number of components is minimum. It's very simple. It just looks at the input. If it goes below a certain amount, it switches on, and that's it. So the offline UPS is the cheapest type and the most simplest. Okay. Now, it does offer some surge protection, but it's very limited because uh, anytime there is a surge or a spike, it may or may not trigger the inverter circuit to start working. So that's what I meant was when I said that the surge and spike potential in this type of UPS, in an offline type of UPS, is very limited. Then you have the two circuits that you have. You have the AC to DC, which is actually charging the battery, and the DC to AC, which supplies power if there's a power outage. Now, uh, the AC circuit fed directly to the load and a feed that charges the battery by a charger. So you have a straight circuit going from the utility to your appliance, and one that goes through the charging circuit. In normal power operating mode, the power passes through the main the main circuit is shown in green at the top where it says current flow. Now, when the secondary is actually charging the battery, making sure the battery is charged up. Now, when normally what will happen is the GPS, in case of a power outage or power failure, the UPS detects that the voltage has gone down in its input, and so it automatically switches the load, so it is fed off the standby battery instead of the utility company. So if it goes below a certain value, the input voltage goes below a certain threshold, or is gone completely in case of a complete power outage, it will switch over to the DC AC inverter and starts giving you power from the batteries. Now, the advantage of an offline UPS is the most power efficient because the charger and the inverter aren't always operating. Okay, Now the charger would only charge the battery if the battery is being drained. The inverter is only working if the utility company power has the voltage has gone down a certain threshold, or there's a complete blackout. So otherwise the inverter circuit is switched off. So in this way, an offline UPS tends to be more power efficient. The last point that I would like to make here is the reliability. Uh, you know, in these days is the technology has improved, and the circuits and the chips that are used in these offline UPSs has improved from what they used to be. But the inverter is only operational when the main supplies fail. Therefore, there's the only test is for this type of UPS is when there's actually a power outage. There's no so it could be that the inverter circuitry is broken, or has a fault in it, but because the utility company is providing clean power, that inverter circuit is not activated. So you don't even know if there is an issue with the inverter circuit. So like I said, this is a drawback, because you when the power goes off, or the usually voltage goes below a certain threshold, that's when the circuit starts working, and that's when you would realize that if there's something wrong with the inverter circuit. So that's a big problem with the offline GPSs. Now, now we have discussed the offline UPSs. Now, let's see what we can find out about the line interactive UPSs. Now, the line interactive UPS is basically if you to put it very simply, it's basically an offline UPS, but the voltage stabilization and the surge suppression and power conditioning is better in excuse me, in case of a line interactive UPS than an offline UPS. Okay, so this the line interactive tends to work kind of sort of similar to an offline, but only better. Okay, now in a normal operation, what happens is the line interactive unit feeds the power through a voltage stabilizer, okay, to the load. So at the same time, it feeds the battery and charges the battery. All right. So what this does is it does offer somewhat of a stabilizing effect on the output voltage. Now, when there is a mains failure, what happens is the load is switched from the automatic voltage stabilizer to the battery to the inverter, which is getting its current from getting its juice from the DC batteries. Line interactive UPSs are more efficient and offer lower running cost than the more expensive online UPS, which we'll be discussing next. These also tend to be cheaper. Okay? The UPS lifetime, in case of online line interactive UPS, is increased as the wear and tear on the batteries and on the inverters is reduced, because the inverter is not constantly inverting the DC power. The batteries are not constantly working to supply power to the inverter. So the inverter life is enhanced, and the battery life is enhanced, as opposed to the next type of UPS that we will consider, which is the online UPS or the double conversion. Okay, but this type of UPS, the issue is it offers lesser protection against electrical frequency differences or distortion, or the harmonics on the input. It does not offer much of a protection there. So even though it's better than an offline, and it's the life is more as compared on the wear and tear, and the life of the battery is better, and the inverter is better in case of a line interrupt than the online or double converter. but it does not offer at the same time. It doesn't offer uh, the, uh, the protection against variation in electrical frequency or harmonics. Okay. Now, that was your line track. So we have discussed the offline UPS, which is the basic. Then we have one step advanced, which is the line interactive. Now, the the most advanced type is what they call the online UPS, or what is also known as a double conversion UPS. Now, what happens is in a double conversion, this, like I said, this is also known as the online UPS. Now, this is the best type of system if you're hooking it up to a generator or longer term backup systems. Reason being, it allows you to, it gives cleaner power to your appliances. Okay. Now, this day and age, most units of 10 kVA, 10 kilovolt amperes, uh, tend to be online UPS or line interactive. And that also nowadays the trend is towards an online instead of a line interactive, just because of the benefits that you get in case of an online UPS as opposed to a line interactive UPS. Now, as opposed to an offline UPS, an online UPS provides provides juice to your appliance, which is a lot cleaner. Okay, it's more cleaner, it's more regulated than the other two types, the offline and the line interactive. So the output that you get out of these systems is a lot cleaner. So if you have more delicate equipment, this might be the type of UPS that you want to go with. Okay. Now, what happens is we also in this type there's also a surge filter, okay, which filters out any surges. It converts the AC into DC. It's charging up the battery. Now that's one part of the circuit. The second part of the circuit, what it does is it takes the juice from the battery, converts it into AC, and supplies to your appliance. So the utility power is not going directly to your appliance. It's first getting converted into DC, going into the battery, and a separate circuit is drawing current from the battery, converting it back into AC, and delivering that to your appliances. So there's a disconnect between appliances and the utility power at all times. So utility power is not going directly from the mains to your to the appliance. Now, the thing is, this does tend to be more expensive though. Okay, the the but the more expensive part is also justified because of the cleaner power that you get. Okay, now like I said, your appliances and the mains utility, there's an isolation. Now, what they also do is there is also a static bypass. Now, what the bypass does is, if in case there is a problem with the AC to DC, DC to AC, if there is a problem, there's a fallback of system in place, which is called a static bypass. What that does is, if it realizes there's diagnostic circuitry built into it, if it figures out that there is an issue with the rectifier or the battery charger, and but the input coming from the utility company is good enough, what it'll do is it'll pass it through to your appliance. But this is only in the case of if there's an issue with the battery charger slash inverter. Okay, otherwise you're always going through the battery charger into the battery, and from the battery into the inverter, and from the inverter to your appliances. Now, excuse me, this is more reliable, more expensive than the other two type of UPSs. And the other thing is, it offers the cleanest possible power that you have of all the three types. Okay, It offers the greatest level of protection against surges and spikes, sags, brownouts, noise, harmonics, frequency disruption in the power that's coming from the utility company. It takes care of all that. Now, the way it does, for example, if you want to know how it handles the frequency difference, that's because the utility power, the power that's coming from the utility company is going into the battery, is converted to DC and then going into the battery. Okay, so if there is any harmonics or if there's any frequency problem in the input, that's immaterial because it's just being converted into DC and it's charging the battery. All right. Now, what the second part of the circuit does is the inverter, it takes the DC current from the battery and then create and converts it into AC. Now, because it's the DC is being converted into AC, it the input from the utility company is not passed through, and if there's any harmonics, if there's any noise on the line on the input line from the utility company, that's not passed through your expensive equipment that you have downstream from the UPS. So that's the three type of UPSs you have. So you have the offline, you have the line interactive, and you have the double conversion, also known as the online. Now, double conversion is because the AC power from utility is converted into DC, and then the DC from the battery is converted into AC. There's two conversions happening. So that's why it's also called the double conversion UPS. So that's all for this video. It was a real quick video just to give you a flavor of the three common types of UPSs that you have available to you. Nowadays, there's extra circuitry that's built into these UPSs. If you're using them in, say, for example, data centers, you can have USB ports or serial ports at the back with which you could connect your servers to the UPS, and when the power goes off, the GPS, if it's smart enough, the new smarter UPSs, they can tell the server that, hey, you're now on UPS power, you're not on the utility power has gone off. And obviously, since there's a limit to how long this any UPS can supply the power, so the smart UPSs, they actually inform, they can transmit the message to the server, your data server, saying that it is now on backup power. Okay, and it will tell the server how long of a backup this UPS can provide. Okay, so say for example, your UPS is only good enough for say half an hour, 30 minutes. So it's as soon as the UPS kicks in, there's a problem with the utility power, your UPS kicks in, your server has is holding all your data or your databases or your files or your user files, user data. That is informed through a link with the UPS that is now not running on utility power, but is running purely on the UPS power. And after 30 minutes, the UPS is going to shut down. So the server, the software on the server will start a countdown as it comes closer to the 30 minute mark. I'm just giving you 30 minutes as an example. It could be different for different UPS, but let's assume it was 30 minutes. So the server is going to say it will start counting down. As it comes closer to 30-minute mark, it will start shutting itself down. If you have SQL databases, it will shut the databases down. If it's running any software, it will shut those programs down and then shut itself down. So it's a more cleaner shutdown as opposed to just suddenly the server not being supplied any juice. So these new UPSs also protect your server hardware in that way. Right? So that was a quick intro into different types of UPSs. I hope you liked this video. If you did, please kind of give it a thumbs up. And if you like to see more videos like this, please subscribe. Thank you.